Hi, in this video, we will make the summary and revision for the thing that you have learned in week 8, which is the introduction to integration method. To master this topic, first of all, you must remember the basic derivative and integral function, okay, as well as the identity for the trigonometric and also some rules such as quotient rule. Let's make some revision here for the basic derivative rule. So you should be able to perform the differentiation for polynomial like this. Let's say you have a polynomial x power of 3, you differentiate 3, you should multiply in front, you get the constant 3, and the power 3 minus 1, you get 2. So this is how we perform the differentiation for polynomial. Next, if you want to perform the differentiation for rational function like this, then you have to be familiar with the quotient rule. Okay? So this is the formula that we use. So we take the 2x plus 1 and then we differentiate the x power of 3 and we take the x power of 3 and then we differentiate the 2x plus 1 and we minus it, okay, and divided by 2x plus 1 power of 2. So this formula is referring to the quotient rule. And then you differentiate x power of 3 here, you get 3x power of 2. Differentiate the 2x plus 1 here, you should be able to get 2 here, right? So 2 multiplied with x power of 3, you should get negative 2x power of 3. So this term, you multiply this, you get 6x power of 3 minus 2x power of 3, you get 4x power of 3. So this is this. And 3x squared multiply 1, you get 3x squared here. Right? And you can further simplify it into this form. So next we look at the exponential function. So you have to be careful what is the base for the exponential function. In this case, the base is 5. So you have to get, after you get the ln 5, 5x, okay, you have to multiply the ln base, which is 5. So for base e, okay, we are familiar with this. Normally you get this answer. Remember that in this case, ln e is 1. So therefore you get it. Next, we move to the composite function. So in this case, you have a polynomial function inside 5 plus 6x squared, and this polynomial function again is power of 2. So what we do, normally we solve the outer function first. So for the outer function, you have to multiply 2 in front and then minus 1 here, and then you continue with the inner part. You have to differentiate the inner part. Okay, so the inner part, after you differentiate, you get 5 plus 12x, which is this. And here you get 2. This one remains. 2 minus 1, you get power of 1. So this is your answer. If you want to differentiate the x sine x in product, we can use the product rule, where we constant the x in front, differentiate the sine, and then constant the sine x, and then differentiate the x. So sine x differentiate, you get cos, so we get this term. Differentiate x, you should get 1, so we get this. Let's record the inverse function. So if you want to differentiate inverse function, in this case we have an inverse function for sine, tangent, and secant. You get something in polynomial a squared plus b squared. So this is the inverse function formula. So to get the dy dx for the inverse function sine here is not so easy. So we have to convert it into x. So x equal to sine y, and then x dy will be equal to cos y, and in this case we can apply the identity. So your cos y should be equal to the square root 1 minus sine square y, and then lastly we should convert everything to the x. So you have your x equal to sine y here, so you can substitute, and then you get the final result. So this form okay, is your dx over dy. You can substitute inside this formula. You get the dy over dx equal to 1 over square root 1 minus x squared, which is this. So we can apply this inverse function rule for all the differentiation, especially for the inverse function. So here you can see that as long as you remember the relationship, so you can see that the sine is related to the cos, okay, positive related to negative here. So by doing that, okay, these are the relationship. By doing that, you should be able to perform this. So this is inverse function also. You can use the same approach to find 1 over x out of the ln x. So you will find that if you differentiate ln x squared plus 1, you have to differentiate the term inside. You get 2x. So make sure you multiply it. So in this form, you can see that if you differentiate x squared plus 1, you get the 2x. So anytime that you see this relationship, if you integrate it, you should get back the ln. So for the differentiation, especially for the trigonometric function, so in tangent, so you have sine over cos. So we can use the quotient rule, which is this formula, to solve it. And then previously we saw that we're able to obtain the second square x if you differentiate the tangent. And for the second, using the same approach, you get the second tangent. So same, by using this relationship, we can transform into these three results. So trigonometric identity is important also. So make sure you're familiar with all the basic equations here and know the reciprocal. Pay attention that this is not equal to inversion, right? So it's not equal to inversion of x. For the angle sum and difference identity, basically we can convert the product here become summation, or the product here become subtraction, which means that if you have integration problem like this one, you want to differentiate it, let's say with respect to x. So in this case, you can directly convert using this identity to solve the sine function, and from here you can get the answer. So x, you have x here, alpha x minus x, basically you get 0. So sine 0 give you 0 as well. So integrate 0 dx, so you should get constant, right? Because if you differentiate constant, you should get 0. Product to sum identities. So in this case, if you have a product like this, we can convert to simple form here, sine only. Okay, so imagine that you want to integrate this. You cannot do so. But if you use this identity, you convert to this form, now you can do it. Lastly, it will be our double angle identity. So if you have a product sine cos, okay, you can convert to sine 2 angle. So this is very useful, especially you want to convert the cos square x into cos 2x. So if you want to integrate this, difficult. So we use the identity, we convert into this form, and then we integrate, and this can give you the answer. So don't forget, after integrate cos, you should get sine 2x, and you have to differentiate 2x inside, you get 2, so you have to divide plus a constant. Same thing, the sine square x can be converted to this form as well. You have to rearrange the term. For example, sine 2x will be equal to 1 minus cos 2x divided by 2. So for trigonometric identity, this will be provided in the appendix normally, and the rest you should always recall and remember. So basic integration rule, you must know how to apply the integration for polynomial, rational function, exponential function, and composite function. So first of all, polynomial function. So at the top you should add 1 divided by the power here. So this is one of the example. And integration normally, okay, if you master the differentiation, it will be just the antiderivative. Next, so integrate 1 over x, you should get ln x. Okay, be careful if you integrate 1 over x squared, this term is x to the power of negative 2. So in this case, you have to add the 1, okay, divided by the power. So if you found the relationship where you differentiate the x squared plus 4 and then you get 2x, the result will be in ln. If you are not confident, you can let u equal to x squared plus 4 and then differentiate it, du, substitute inside, okay, you can get the same answer. So for exponential function, if you integrate the exponential x, in general it should be divided by the ln base. So in this case, ln e can be cancelled because it's 1. So you get this answer. So for any exponential function, the base, okay, you should be divided. Composite function. So in this case, we can use the substitution. So you let t equal to this. If you differentiate dt over dx, in this case, exactly the same with the 5 plus 12x dx here. So you just solve the t. So what you get is t squared over 2. So 2 constant can be cancelled off, where you get the t only. So t squared, okay. So in this case, back substitute your t inside, so you get this answer. So this is substitution. Integration by part. So if you see a product term like this, you have polynomial and trigonometric, and then these two functions can be solved by using the integration by part. So if you want to integrate this, you select u, okay, and dv. So dv in this case is cos x dx. So we have a uv minus v du formula for x cos x here. Next, inverse function. So we use the inverse function rule when you want to integrate the inverse function. So in this case, if you have an inverse function like the inversion function for sine, so we are actually looking for the area too. However, it's very difficult to integrate this. Therefore, we have to integrate the other way, which is we integrate with respect to y, you get the area 1, which can be found from here. So this can be done much more easy, where you let x equal to sine y, and then you integrate this part. So the total area is xy. So total area minus with your area 1, you should get the area 2, which is what you want to solve. This is the example. So if you found inverse function like this, you can integrate it using this inverse rule. Next, you have trigonometric function. Don't forget the integration for sine, tangent, and secant. And by using this relationship, you should be able to obtain the integration for cos, cotangent, and cosecant. So besides that, we can also integrate the secant square, okay, where previously we differentiate secant, you get secant square. So integrate should be the antiderivative. So you should get this answer, second tangent, you can directly get the answer as well. There is typo here, so this should be tangent, and then this should be negative cotangent. So these are the important formula that you must master, and this is always provided in the appendix. So integration by part is very important technique in integration. So you have to choose the u and dv for the formula uv minus v du. So as a rule of thumb, we choose u for those which is difficult to integrate. So for example, ln, okay, inverse trigonometric function, so it's hard to integrate. So let's say you have a product here, x and ln x, so we can use integration by part. So we choose u equal to ln x, okay, because it's much more easier to differentiate here. So you also learn about the substitution. So sometimes it may involve the trigonometric identity to solve this kind of problem when you use the identity together with the substitution to solve the problem. Okay, so we have discussed this earlier, and you can see that we can do a lot of substitution to solve various problems. And sometimes you found some problem cannot be solved easily by using substitution. For example, like we have a square plus b square case. So in this case, you have 1 minus x squared. So we should use the trigo substitution. So if you recall previously, when we integrate 1 over square root 1 minus x squared, you get something in sine. For this one, you get tangent, and lastly, you get secant here. So when I look at this is a squared minus x squared, which is this form, first form. Therefore, my trigonometric substitution should be in this sine form, and then a squared is 3. So next case is tangent, right? Because you have x squared plus b squared a squared term, and your a is to be equal to square root 6. And last case, okay, if you have x squared minus, okay, a squared, where your a is 1. So in this case, your a is square root of 15. So because it's negative, so this should be secant. So from this assumption, okay, you can form the triangle here. So x over 3 give you the sine. So you can find the distance here. You will see that this is exactly the same form here. And for the next case, you can see also the same tangent x over square root 6. Second is the 1 over cos. So your cos to be square root 15 divided by x. So your cos angle should be square root 15 over x. Okay, improper rational function we can convert to proper one. So for example, here you have x power of 1, degree is 1 here, at the top you have 3. So in this case we can further reduce it by using long division. So this is the long division. By doing this procedure, you should be obtain the result, okay, and we can write the result in this form: x squared plus x, and then you have 2x as the remainder. Lastly, your factor remains here. So you check again. If this one is still improper, then you should further continue the long division. to solve it, and you get the remainder, and then you rewrite the equation. So 2x divided by x minus 1, this term you get 2, okay, right there, divided plus the 2 divided by x minus 1. Right? So this is more example. So in general, you should master the skill for how to convert improper rational function to proper function. Next, we also learn about the factorization, where given a polynomial function, you find the root either by using the calculator or the step that you have learned in this course. So from the root, okay, you can form the linear factor. The root can be estimated from the constant behind here also. So for the second case, you might have repeated linear factor, which is this term. So you have also distinct quadratic factor in this term. So you have linear factor. So when you have linear factor, there should be no issue to get this. So for the last case, okay, if you have no linear factor, then you have to proceed with the case to find the quadratic factor. You also learn the completing the square technique. So for example, to solve this, so you check, you cannot further reduce it to any factor. Linear factor cannot, quadratic factor is the most simplest one so far. So firstly, you can do factoring, okay, and then from this term we can do the completing the square, and from here you can see that negative 6 here you have to divide it by 2, and then this, the same term, you have to minus it. Okay, so you get this result. Partial fraction, so you have 4 cases here. For the first case, you can see all of them is linear factor. So for linear factor, you are going to find the unknown constant a, b, c. For the repeated linear factor here, so don't forget it should be x minus 1 up to the degree here 2. So if this is power of 3, then you have to add another term b over x minus 1 to the power of 3, and so on, right? So if this is 4, you have to add additional term. So to integrate this, where you can see the root is complex number, so you cannot reduce it further to linear factor. So if you still want to find the linear factor here, like this form, so you perform the completing the square. Then we have a repeated quadratic factor here. In this case, you can see this is the linear factor, you have constant. For quadratic factor, you have linear factor at the top. Bx plus c, you are going to find the a, b, c, d constant for this case. And repeated factor here is power of 2, so you have power of 1, power of 2 term here, same. So if you have power of 3, then you have to add fx plus I, let's say. So you have x squared plus 1 here to the power of 3. Is it? So these three identity, make sure you're familiar with it.